In this video, I will be going over the second problem in the Exam 1 practice problems. So the problem says you've just landed an excellent job and want to start depositing money into a savings account each year. You'll begin at the beginning of this year by putting $5,000 into the bank that pays 9.542% annual interest compounded daily. You plan on increasing the payment by $500 per year. Year 2 will be $5,500, year 3 will be $6,000, etc., until you retire in 20 years. How much will you have in the bank at the end of 20 years? So there's a kind of two questions within this problem. One is you need to convert the interest rate here to an annual rate. Because of this word compounded, it indicates that this is not a effective rate. It is a nominal rate. So you need to make that calculation in figuring out the interest rate. And then the second thing you need to do is to figure out what the future value is of this investment. So let's first of all look at converting the nominal to the effective rate. And we'll use the equation because this is a yearly rate. We're going to use the equation I is equal to 1 plus r over m to the m minus 1. The values are for R, which is the nominal interest rate, is 9.542%. M, which is the compounding time periods per year, is 365 because of the word daily. It lets you know it's 365. So we plug this in and we get an equation that gives us 10% interest rate. So now we can go ahead and draw this calculation, the cash flow, as and put it in 10% and then put the values in there. So what we're going to do is, this is a gradient, and I know I told you I wasn't going to really talk much about gradients in this class, and I won't be testing you on it, but I'm going to go ahead and explain this just as a way of working through this problem. So gradient always starts with an A value, which is equal to the first cash flow, and then we add to that a gradient, which is the increased value in every time period. So in this case, we have the increase of $500 per year. So the G value is 500. So I'm going to go ahead and put an equation together to figure out what is the future value of the first annual payments, F given A, 10% for 20 years, and then the gradient, F given G, 10% for 20 years. But in our tables, we actually don't have an F given G value, so we need to do something else. We have P given G, so we'll go ahead and first of all calculate the present value of this gradient and then move that all the way to the future value. So I'm going to be using two factors here. One, first of all, I take this whole gradient back to time period 0 by getting a P, and then I bring it to the future value by multiplying that by an F given P. And that then I look up those factors and I get a value of 472,749. Now we're going to look at the second part of this problem, which is in 20 years you want to take a trip around the world and you want to know how much you can live on each year during your trip. Take the sum of your calculated in part A and determine how much you can withdraw each year for 10 years. So what I want to do is I have 427,745 and I want to know how much I can withdraw every year for 10 years. So I'm just going to find out what is the A value given this present value, and it ends up that I can withdraw 76,916.